For our last example of the section, we want to graph the equation r squared equals 4 cosine of 2 theta. So as before, we're going to start with symmetry. So we're going to check each of those cases where if we want to look for polar axis symmetry, we place in that negative theta for theta, and we see that that doesn't change anything for the same reasons as before. Next, we're going to check with the symmetry along the line theta equals pi over 2, where here, because r gets squared, the negative goes away on that side, and the negative still goes away from theta on the other side. So we also have symmetry with that vertical line. And then for polar symmetry, the exact same thing will happen. So we also have symmetry with the pole. We actually have a great deal of symmetry here. So we don't actually need to do a whole lot in terms of graphing this. And it's actually kind of convenient as far as being able to check our values go. Really, all we need to do is get halfway up in the first quadrant, because beyond that, the other half can get pulled over by symmetry with both poles, and then that symmetry with the line will clean up the rest. So, taking a few values, at theta equals 0, thanks to our symmetry, we plug that in there, and we will get r is equal to plus and minus 2, that squaring relationship, at pi over 6. And it's a little less clean because you multiply that value in, you multiply in some 4s, and you take some square roots, you get plus and minus 1.4. And then finally, at 0, you will get, at pi over 4, you will get 0, making a shape like that looks like an infinity. This is what's called a lemniscate, where lemniscates have two main patterns, essentially. They are r equals a squared sine 2 theta and r equals a squared cosine 2 theta for non-zero a, where the symmetry we get is dependent on whether it's in terms of sine or cosine. And this is essentially all we have for this chapter, our discussion of snails and flowers and infinity shapes. That is, next we're going to move into section 6.5, where we're going to get into something, I'd say, a bit more conceptually dense. We're still going to see some sines and cosines, which is why it's in this chapter, but there's a lot more going on with the complex numbers that we're going to see in section 6.5.